From towering cane fields to sparkling crystals, sugar's journey is a precise blend of tradition and technology. Inside modern factories, crushing, purification, evaporation, and crystallization works in harmony, transforming raw plants into the sweet, refined ingredient that fuels kitchens, industries, and daily life around the world. So let's dive in. Imagine standing amid endless rows of towering green stalks stretching toward the horizon. Welcome to Brazil, the world's sugarcane powerhouse, producing over 700 million tons annually, more than any other country. Sugarcane is not just another crop. It's incredibly efficient, boasting a natural sugar content of up to 16%, far higher than corn or wheat. This efficiency is why just 10 stalks of sugarcane can yield a kilogram of sugar, making it the ideal raw material for sugar production. The sugarcane plant itself might look a little unassuming, but it fuels a global industry valued at over $40 billion. The cycle begins with the harvest season, a time when vast fields buzz with activity as machines and workers prepare to extract the crop's precious sweetness. In the golden fields of the sugarcane belt, a centuries-old cycle approaches its dramatic climax. The air is thick with anticipation, the stalks heavy with sucrose. The question echoing across these landscapes is a stark choice between tradition and the future. Fire or steel? Before harvesting, many farmers still practice a method known as burning the fields. For generations, preparing for the cut meant embracing the flame. Fire, a fast, efficient, and cleansing spectacle that stripped the cane of dry, sharp leaves and sent pests scattering, was used frequently. It might sound a little counterintuitive to set your crops on fire, but these controlled burns remove extra material like dry leaves, tops, and insects, leaving the stalks clean. All that extra material can slow down processing and drive up transportation costs. But because burning creates smoke and pollution, it's now heavily regulated or it's being replaced by newer methods. Today, the revolution is mechanized, quiet, and green. The roar of the fire has been replaced by the precision engineering of modern machinery. This is the era of green harvesting. These precision-engineered machines cut the cane stalks close to the ground without damaging the roots, allowing the plant to regenerate for future harvests. As they move through the rows, rotating blades slice the stalks, while onboard separation systems remove leaves and tops. These leftover parts aren't wasted, they return to the field as mulch, enriching the soil. These mechanical behemoths don't just harvest, they steward the land. They leave the nutrient-rich residue as a natural mulch, feeding the soil, retaining moisture, and locking carbon in the ground. Preparing for harvest is no longer about clearing the fields, it's about sustainability. The harvested cane is cut into manageable pieces, briefly stored inside the harvester, and then transferred to trucks waiting at the edge of the field. The pace here is relentless. While a crew of manual laborers might work all day to match the output of a single machine, these mechanical giants process between 80 and 120 tons every single hour. It's a staggering display of productivity, the engine behind large-scale agriculture, ensuring the world's demand for sugar is met day and night. The harvest is only the first act. Once cut, the clock starts ticking. Sugarcane is a perishable cargo, so every hour lost means the sugar content drops, fermenting in the tropical heat. This critical race from field to factory is where logistics meets industrial ambition. The transport phase is a logistical ballet. The cane, packed tightly into massive trucks or sometimes transported by dedicated narrow-gauge railway cars, converges on a single destination, the sugar mill. Samples are also tested in on-site laboratories to assess sugar levels and quality. At the factory gates, order emerges from the chaos. The loaded trucks queue, waiting their turn for the weighbridge and then the dramatic tip. The entire truck bed is elevated, spilling its mountainous load onto a massive feed table. It's here that the cane begins its transformation from raw agriculture to a refined product. Upon arrival, the cane undergoes a thorough cleaning process. High-pressure water spray removes soil, sand, dust, and other impurities that could damage crushing equipment or degrade juice quality. Clean cane is essential for producing pure sugar. Next, the long stalks are chopped into smaller pieces by cutting machines, facilitating efficient feeding into crushing rollers. The heavy steel cylinders squeeze the life out of the stalks, extracting the super sweet raw juice. This fibrous residue, the bagasse, isn't wasted. The fibrous residue after juice extraction has become a symbol of sustainable sugar production. Instead of wasting this byproduct, factories convert it into eco-friendly materials such as biodegradable plates, cups, and bowls. At specialized recycling plants, bagasse is washed to remove impurities, then pressed and cooked at high temperatures with natural binders. The pulp is molded under heat and pressure into various shapes, dried to reduce moisture, and coated with plant-based waxes to make it water-resistant. It's also channeled into the factory boilers, powering the entire mill complex, making the operation self-sufficient. Back in the factory, the raw cane juice still contains fibers, dust, and organic residues. To clarify it, lime is added, which reacts with impurities, causing them to settle out. This purification step is crucial for producing high-quality sugar. The juice then passes through a multi-effect evaporation system, where water is gradually removed under controlled heat and pressure. This thickens the juice into a dense pale yellow syrup, the precursor to sugar crystallization. Inside the heart of the sugar mill, the journey of the sweet juice approaches its moment of truth. The purification is complete. Now, chemistry and engineering converge in a delicate process, the crystallization. This isn't simple boiling. In these vast, sealed vessels called vacuum pans, pressure is reduced, allowing the syrup to boil at a lower temperature, protecting the fragile sugar molecules. The liquid thickens into a heavy, viscous mother liquor, a mixture of crystals and syrup. The pan boiler is a maestro, carefully managing temperature and concentration. Tiny seed crystals are introduced, providing a foundation for growth. As the water evaporates, the dissolved sugar rapidly gathers around these seeds layer by layer, forming the raw golden crystals we all recognize. The pan boiler watches the grain line as it forms, ensuring every crystal is perfectly sized, uniform, and pure. Once the crystals reach maturity, it's transferred to a different kind of machine entirely, the centrifuge. These are the workhorses of separation, spinning at incredible speeds, harnessing G-forces to perform the final extraction. The centrifugal force flings the dark, sticky molasses through a fine mesh screen, separating it from the dense, solid sugar crystals that remain in the basket. The raw crystals are sprayed clean with a hint of hot water. This step is a key to differentiating between raw brown sugar and refined white sugar. Brown sugar retains 3 to 5% of its natural molasses, lending it a rich color and a caramel aroma. White sugar undergoes further refining to remove almost all molasses, yielding pure sucrose with a bright white appearance and clean sweetness. What emerges is the raw commodity, tumbling onto conveyor belts, ready for the final steps of drying and cooling. From an opaque liquid in the field to a glistening crystal in the factory, the final product is prepared for its journey to markets around the world. The cycle is complete, delivering pure, clean energy born from the sun and soil. The journey doesn't end at the raw sugar mill. While perfectly usable, raw sugar still holds impurities in a rich golden hue. To achieve the pure, sparkling white standard demanded by global markets, it moves to the refinery, an operation built on pristine purity. Here, the process begins again. The raw crystals are dissolved in hot water to create a syrup. This solution undergoes clarification and filtration, often using carbonation or phosphation processes to trap residual impurities and colorants. The goal is simple: absolute clarity. Once it's decolorized and filtered, the clear liquid is boiled down again into a supersaturated solution in specialized vacuum pans. It's recrystallized, this time resulting in the brilliant, perfectly white crystals known as refined sugar. After a final spin in the centrifuges and a pass through drying coolers, the pristine sugar is ready for its final form. Automated lines whir into action, weighing, filling, sealing, and packaging the final product into the familiar bags and boxes that line supermarket shelves worldwide. Metal detectors also ensure product purity, and each package is labeled with expiration and traceability codes before shipment to markets worldwide. While sugarcane dominates tropical regions, sugar beets play a key role in temperate areas like the United States, producing about 55% of the country's sugar. Grown primarily in states like California and Michigan, sugar beets provide sugar as well as residual pulp for livestock feed. Sugar beet processing shares similarities with cane sugar, but begins with harvesting the root vegetables using specialized machinery that lifts and cleans beets before it transports them to factories. In the mill, beets are washed and sliced into thin strips to increase surface area. Then they're subjected to hot water extraction to dissolve the sugar. After extraction, the raw juice undergoes purification using lime and carbon dioxide to precipitate impurities. The juice is then concentrated in evaporation towers, sometimes using vacuum technology to preserve sugar quality. Crystallization follows, with seed crystals added to encourage sugar formation. The crystals are separated from molasses through centrifugal force, dried, and packaged similarly to cane sugar. The molasses separated during this process is often repurposed for animal feed or fermentation products. The journey of sugar beet processing is a remarkable blend of agriculture, engineering, and chemistry. Each step from field to factory is optimized to maximize sugar yield while minimizing waste and environmental impact. From sprawling sugarcane fields in Brazil to beet farms in the United States, the journey of sugar is a fascinating blend of agriculture, chemistry, and engineering. Modern sugar factories demonstrate incredible efficiency by fully utilizing every part of the sugarcane and beet plants, turning byproducts into eco-friendly materials and livestock feed, minimizing waste. The next time you sprinkle sugar into your coffee or bake with it, remember the complex and carefully choreographed process behind every crystal, the dedication of farmers, the precision of cutting-edge machinery, and the sustainable innovations that aim to balance industry with environmental responsibility. Sugar is more than just a sweetener. It's the product of an extraordinary journey from field to table, a testament to human ingenuity and the power of nature combined.